So have you ever traveled to a scenic spot to catch an incredible sunset or sunrise with distant mountain peaks bathed in the most beautiful pink and orange alpenglow, only to find out that they're unexpectedly in the shadow of some unknown obstacle? Well, hey everyone, this is Mike Shaw with Planit Pro, and in today's video tutorial, you're going to see how you can use the light feature on the light and shadow page to pick the date for perfect sunset and sunrise light so that this never happens again. Now, as you know, the sun and the moon are the two most commonly used natural light sources, and there's two ways to use them as light sources within your photography. The first is to include them directly in your composition. In other words, either or both of the sun or the moon are visible directly within your viewfinder. And the second way is to let the light from the sun or the moon shine on your subject from outside the composition, so this way neither one of them is directly within the composition. Now, before we get into the details of how to use the light feature in this case, let's step back a little bit to explain how different locations are used in Planit Pro to calculate the ephemeris information that's displayed on the various screens. And as you probably know, there's always two very important locations on the map that you select. The first is the camera location. That's where you're going to be standing with your camera. And the second is the scene location. Sometimes this is a specific object, sometimes it's a general direction. But both of these points, the camera location and the scene location, are points that you pick, as we've discussed a few times before. And we've also covered these in a separate tutorial you can find under the help button right down here. Okay, so now let's start by looking at the first ephemeris page, which is the rise and the set tool, as you can see right up here on the left. Now you'll notice how the rise and the set azimuth lines for the sun and the moon all originate from the camera location right just here. And that you can see with this blue pin. And this makes sense because we're generally wanting to know about the sun and the moon location from the perspective of the camera. And if you switch to most of the other ephemeris pages, you're going to see basically the same thing. In other words, the camera location is the location that's used to calculate all the data for sunrise, sunset, moon position, sun position, and lots of other things. And this is important if you remember that we're talking about if we're interested in including the sun or the moon in the viewfinder as a part of the composition. Now, look at this. See how all of this changes the moment we switch to the light and shadow page, like this. Now, when we do this, what you can see is the ephemeris pages now come from the scene pin, or the scene location, and that's denoted by this red pin right over here on the subject or the scene. And what this means is that in contrast to the other cases, here, we're going to use the scene location to calculate the ephemeris information on this page, not the camera location. And this is a very important distinction. And this is particularly important for the second way of using the sun and the moon. And this is when we're interested in having the sunlight or the moonlight shine on the subject, like we mentioned at the beginning of the case for having our mountain peaks in sunlight instead of having them in a shadow. And the light and the shadow tool in Planit Pro is the only page that uses the scene pin in this way for this purpose. All right, now in our previous tutorial, we've already talked about the first row on this page when we talked about the shadow tool. And when you may remember that this is also super useful for alignment shots with the sun or the moon. And now what we want to do is we want to take a look at how to use the light feature. Now the first step is to set the scene location to the subject that you care about for the light condition. In other words, the mountain peak or the building or whatever you're interested in. And we've already done that in this location. We've set the red scene pin on top of Half Dome in Yosemite National Park, which you can see right here. This is the case because what we're interested in this example demonstration is finding out how the sunlight conditions on the vertical face of Half Dome are. In particular, we want to find dates when sunlight shines directly on Half Dome during sunset so that it's not in a shadow. Now the second step is to adjust the time to sunset or of course, in other cases, you could choose sunrise, and we're going to do that right down here. In our case, Half Dome faces predominantly west, basically, so it's mostly a sunset location. Okay, now check this out. You can easily get to the sunset time by tapping this green Next Event button until you reach the sunset event. And so like this. And then once you do that, you can see here that the sun elevation angle is negative 0.2 degrees. Indicating that it's just below the top of the sun, is just below the horizon. Now you can see what it says here on the second row. It says, in the shadow, meaning at the current sunset time and date, the sunlight will not reach the top of Half Dome. Bummer! All right, you can also see that there's a 0.2 degree indicated warning indicated here, And that means that as long as the sun is above 0.2 degree elevation, the sunlight will reach the face of Half Dome. Now, you can tap as indicated here for more details. And this brings up a terrain profile along a line between the scene pin and the sun. How cool is this? You can tap on it like this to zoom in. And if you look carefully, what you can see is somewhere along this line, there's a high point that blocks the sunlight. That's pretty cool, right? And you can even find out exactly on the map where the high point is like this. First, notice that you can tap on any row to highlight that point along the profile with a little red dot like this. So I tap here and you can see the little red dot right here. Next, you can scroll down to find the row with that high point. So see here where the 364th row says plus 0.2, and that indicates that this should be the point pretty close by that's blocking the sunlight. Let's find out. We'll tap on it to mark the point on the profile like this. And yep, that's right about here where you see the little red dot. So next, we can long press on the 364th row like this. And what that does is it brings us back to the map and centered at the location of that high point, which is pretty cool. So let's go ahead and add a marker just like this. And then we're going to zoom out a little bit. And what you can see is here's the sun direction line at sunset. And you can see, okay, right here that it passes right through the high point near these surrounding hills. Okay, so now we can also switch over to the terrain map to see the overall terrain details. This is going to be very helpful in a lot of cases. And as you can see, there's no problem around here. It's only really up at this marker location where the scenery or the terrain is too high. Well, okay, well, let's try a different date. How about a date in February? So let's choose a February date. Now, by the way, notice this sunset event color up here. This is in white, and that means that it is a sticky event. Now, when an event is sticky, what that means is that you can adjust the slider to a different date, but the event itself will be kept the same, even though the time is changed because you've changed the date. So watch this time here while I drag the slider to a different date, like this. And what you can see is that the time changes on the different date, but the event remains sunset. And that's what we mean by a sticky event. You can watch the date and time video tutorial to get more details about how to use that. All right, so now that we've done that, let's go back to try a date in February, like this. And now you can see that the sun direction is good since it's aligned with the Yosemite Valley. And when we check up here, like this, sure enough, our scene, Half Dome, it's under the golden sunshine. Okay, so that's a good thing. And in fact, as you can see right here, as long as the sun is above negative 0.8 elevation angle, which is quite low, it's going to be the face of Half Dome is going to be under golden sunshine. And this is a much better result than the limiting case of plus 0.2 degrees on the previous date in April. Now just imagine that if you take a photo of Half Dome at this time in February, Half Dome is going to be lit up by the setting sun from the west in a beautiful, beautiful red color because the sun's so low, nice and low on the horizon. And in fact, we can tap up here to get more details about the profile. And what you can see is that there aren't any high points along the sun direction line. And this means, that makes sense, because that means that the sunlight can reach Half Dome okay without getting blocked. So what all of this means is that on February 24th during sunset, assuming there's no clouds, Half Dome is going to be lit up by the sun in this beautiful red color. And not only is the red area going to be larger, but it's also going to last longer than the sunset on April 24th. So definitely would be a better choice to go for sunset on February 24th than on April 24th. Now, I hope this has been useful so far. Like myself, you may have thought that Half Dome always gets lit up in red pretty much for every sunset, but clearly that's not the case. So let's go check out another example, Torres del Paine in Chile. Now look how gorgeous it is lit in red alpenglow during the sunrise. And while you might think that it's going to be lit with red alpenglow every sunrise as long as there's no cloud blocking it, guess what? Turns out not to be the case. So for example, we know someone who went there in 2016, and before they entered the park, they asked a ranger if they could see the peaks in red light, And the ranger said, no problem. So off they went, and this is the photo that they got. Now while the peaks next to Torres del Paine is red, Torres del Paine itself is in shadow and clouds, unfortunately. So let's see why this is so. And again, as you can imagine, you can find the answer right here using the light feature that we've been exploring. Now to do so, I've switched the scene location to the top of Torres del Paine and the date and the time to the date and the time when our friend visited. Now look here on the second row. As you can see, it says shadow. Bummer. And just like before, we can tap right here to see the details. And in fact, the sunlight is indeed blocked at sunrise. Now, keep in mind that even if the sun is blocked at sunrise, as long as it's not blocked a few minutes after sunrise, it's still okay. The peak will still be in a red alpenglow as long as the time is real close to sunrise, usually within a few minutes. So let's adjust the time down here to make the sun go higher, like this. Just say a little over a degree. And nope, it still says in shadow. We can tap up here to find out what's going on. And yep, it's still blocked. How about a little bit later? Okay, so here a few degrees. Finally, it says golden sunshine. However, the sun is now a little too high in the sky to light up the peak in that nice red alpenglow you get only within a few minutes of sunrise or sunset. So let's just go ahead and let's just find out where the mountain is that blocks the sunlight. Again, we can scroll down and tap the row like we did before to find the row with a high point, and here it is. And then we can long press on that row, and that's right here. And we can again add a marker to mark the location just like before. Now, if you want to visit the area without the same thing happening to you with the shadow on the face of the mountain, you should take a look at what we're about to do next. Again, so to choose the good days. This is basically what we did up in the Half Dome in Yosemite. All right, so let's try a date in January, and it's still blocked. How about February? That works. Okay, that's a good thing. Okay, let's check April. Nope. And we can also tap here to look at the details like this. And when we look at this, it looks like the blocking mountain is now further away than the December one. So it's a different one. And that makes sense because the sun angle has changed direction. Okay, we'll go back. What about June? Nope. July? Nope. August? Nope. So in fact, what we've seen so far, lots of months aren't so great for this. And the reason for it is that Torres del Paine is not the highest peak in the mountain, and it's easy to be blocked by the surrounding terrain. And that's why it's important to check the light feature in Planit when you plan to go there or anywhere else you're counting on a similar sunrise. Now, let's come back to Half Dome, and we'll show you one last trick. We'll also go back to the date of April 24th, since we know that Half Dome is in shadow at sunset then. Now, for natural subjects, we're going to basically use the built-in elevation data that's automatically accessed to find out the light condition. In other words, whether the sunlight is going to reach the location. But suppose you're interested in a building, and you want to find out if the sunlight's going to hit the top of the building rather than the landscape. And in this case, you just need to enter in the height yourself, which is super easy to do. So just as a demonstration, since we don't have any data for building heights in Yosemite, we're just going to enter a hypothetical subject height right just here, for example, 1,000 meters. And when we do that, what you can see here is it says that the subject is in golden sunlight. And basically what we did is we lifted the subject up into the sky, and now when we tap to see the details, if you look real closely right over here on the left-hand edge, you might be able to make out this tiny little stick at the scene location, and that stick represents our subject height of 1,000 meters. And from looking at this graph, you can easily see why it's in golden sunlight. It's above all the surrounding obstacles. Now, of course, what we just did doesn't make any sense at all for Half Dome because there aren't any 1,000-meter buildings on top of Half Dome. It's just a demonstration. But if you're in the city where you do have tall buildings and you'd like to try to capture them above a shadow, it's kind of a neat photo opportunity. You can set the subject height right just here, and this will give you a more accurate result of the lighting condition. Well, that's it for this video tutorial. Once again, this is Mike Shaw with Planit Pro saying thanks for watching, and we really hope you enjoy planning your perfect lighting with Planit Pro.